My name is Kirby. This is my Python function here, or my Python code. Generates a solar system with 3D cubes. So we're going to run through a few. We have our rings. These are these rings here. I'm going to skip over those because that's really simple. We have our orbit. This is really fun. It uses cosine and sine to basically make a circle. It's like the unit circle, but we convert all of our angles to radians because you got to have radians because cosine and sine use radians rather than the angles in Python. Mini orbit works pretty much exactly the same. Orbit returns x and y coordinates for the center position of whatever shape you are drawing as your planet. Mini orbit does very similar things. Using that inner planet position, it will draw a ring and then set our center position equal to orbit. So we get another coordinates of where we want our secondary planet. And then we paste our shape, which will be a function, either draw cube or generate 3D circle, or it could be something else if I made a different function. And that will take size, center position, color, loop number, which is the I for the rotation in the cube. You'll see here 3D circle has 2 extra values to just ignore those, and then we'll paste that image. Next, we generate our 3D circle function here. It makes sphere image on a transparent background, so that way we don't draw an endless like line, so that way it's a transparent image. And then for range, we slowly from the outside, we take the box of the ellipse and slowly collapse it. Should have made this circle and just filled it. Would have been easier, but I was trying to do some shading and then I kind of just deleted it to make it look better. Cube is fun. We take our center position. That's where the center of the cube or the coordinates are going to be relative to the screen. This is basically like x0, y0 on a normal graph. We take half of our size to make sure all the points are equal distance from the center of the cube. All vertices should be equal distance. Our vertices are listed here as negative half, or some combination of half, negative half, half, something along those lines. All negative half, back, bottom, left. All positive are front, top, right. So you can see how they're opposite. Convert our angles to radians because, once again, cosine, stuff like that. Our rotated y, we're going to rotate y first using x and z. We're going to then append that to rotated y for x new, y new, z new. And this is the fun math part. I'm not going to go into that as much as I don't have enough time. Just normal rotated takes the rotated y list and swaps out x for y, and then appends it back to that list, keeping x the same because we're rotating around the x-axis, so x won't change. Next, we are going to project to 2D, pretty much adding center x and center y together and making that into a list, which is used later. We define our faces, which are each of these, so 1, 2, or 0, 1, 2, 3, all the way to 7. You get the idea. And then we take a calculate for the z. We are taking the z position of each of these. So it'll give us the position of 0, what the z index is for that using the rotated list. It'll add all those together, average them up, and then append that to face or face depths. Then once all of those are run through, we'll have a depth for each face here. So each one of these will have its own depth appended to it in a different list. And then we're going to iterate through that list and find the minimum value, add that to sorted faces, and delete or pop it from the face depths. And then once we're done, we'll get a perfectly sorted list. And then for item faces, this just prints from the farthest back away from the camera to the closest, so that way we get just the top ones, so there's no weird overlaying. And then we return that image. Here we iterate through all 360 frames, and we do 4 iterations from here, and J is used for the offset just to make it look a little bit nicer and give it an offset. And every 90, or each iteration of J, I should say, it makes a new planet. I could do more, I could do less, but it just was easier to do that. It pastes that, and then each time it will paste that. This is not important. And then we will paste our central cube, and I is used to rotate the cubes. and then we'll append our frames. And this is all in the eye, so it appends frames each time, and once it's done, you're left with this.